In the previous lesson, we briefly talked about variables and constants. You learned that the var keyword declares variable, and the let keyword is used to declare a constant. Both variables and constants store values that can be referenced by a name. There is one obvious difference that we didn't discuss though. The value stored in a constant cannot be changed. The compiler throws an error if you try to modify the value of a constant. Try it out. Create a new playground, like we did in the previous lesson, and add the following two lines to your playground. We are in luck though. Xcode gives us a hint to fix the problem. Click the red circle on the left to find out what Xcode suggests we do. Xcode is clear about what we need to do to fix the problem. In Swift, a variable is mutable, while a constant is immutable. That is why Xcode suggests we replace let with var to make number of wheels mutable. The value stored in a variable can be changed. If we replace let with var, the error disappears. The only difference with the previous example is the var keyword. Why would anyone want to use constants? Variables seem to be much more flexible. When you use or encounter a constant, you can be sure its value won't change. For a developer, that is a bold promise. Constants add safety to your code, and safety happens to be a fundamental concept of the Swift language. The bottom line is to use constants for values that won't change, and variables for values that will change. Swift is a statically typed language. This means that every variable and constant has a type. In our example, number of wheels is of type int, an integer. But how does a compiler know that? In most cases, the compiler is clever enough to infer the type of variables and constants. In our example, the compiler inspects the value that is assigned to number of wheels, and it infers that number of wheels should be of type int. This is better known as type inference, another powerful feature of the Swift language and the compiler. The type of variables and constants cannot be changed. Let's assign a string to number of wheels. It doesn't take long for the compiler to complain. The error message shows us what the problem is. We attempt to assign a value of type string to a variable of type int, and that is a no-go in Swift. Remember that the type of variables and constants cannot be changed. Type inference is great, but it's also possible to explicitly declare the type of a variable or constant. In the next example, we explicitly declare maximum speed as a float. We tell the compiler that maximum speed is of type float. That's what the colon in the expression stands for. The Swift standard library declares a wide range of types. Let's take a quick look at the most common types. We already covered integers and floats. But the standard library also declares several other number types, such as double for more precision. Strings are very flexible in Swift. In this example, we declare a constant str1 and assign it a value using a string literal, a predefined string value. We can also use an initializer to create a string. We cover initializers later in 30 Days of Swift. To assign a value to str3, we use a combination of a string literal and string interpolation. String interpolation lets you create a string from a combination of variables and constants by including the values in a string literal. The example illustrates how this works. Notice that each value is wrapped in parentheses prefixed with a backslash. That's how string interpolation works in Swift. The Swift standard library declares three powerful collection types: arrays, dictionaries, and sets. We cover collections in more detail later in 30 Days of Swift. These examples should give you a taste of collections in Swift. In the next lesson, we take a look at tuples and optionals. With tuples, you can group several values into one value, a compound value. An optional is a special type that adds another layer of safety to your code. If you have any questions, leave them in the comments below or reach out to me on Twitter. And don't forget to subscribe if you want to learn more about the Swift language and Cocoa development.